we'll talk more about navigation and mapping. So let me share screen. All right, so before we get started, everybody should familiarize themselves with the Erebus rules. And right here, if you go to their GitHub wiki page, they have a list of helpful resources as well as the rules. And what's important to note is the point scoring. So as of right now, you get a point for picking up a victim as well as returning a victim. And you get an additional point if the victim is a child. There's also these activity blocks on the field. And you don't get any points for picking them up, but you do get 5 points for depositing them in the proper location. So what's important to note here is that it gives you the detection colors of the base as well as the victims. So this is going to be useful for when we do camera recognition because each object has a detection color associated with it. For instance, the victims are 000. So that would tell us when we're using camera recognition what object we're actually looking at. So the base is 0.301, and these activity blocks are pretty much their own color in terms of recognizing them. All right, so if we go back here, I have some, I'm gonna put this. I have some code written already. We're gonna introduce 2 techniques to victim retrieval. One of them is gonna be a lot simpler and not require as much math. And the other one is gonna require a little bit of trigonometry for those of you who have learned more geometry. So first, we have to talk about how you're gonna iterate through a list of recognized objects. And most of the time, your camera view will pick up multiple objects in a single frame. So it's your job to go through all of them and extract actually what you want. All right, so for instance, if I run the simulation, you'll notice that there are a bunch of red boxes within the camera view. So each of these red boxes is supposed to be a recognized object. And you're gonna have to get a list of these recognized objects and then go through them one by one to find out what you actually want. So how you do that is pretty simple. And I have my main while loop here in the code. And I'm gonna walk through you guys this script really quickly. This num object, I just create a variable that stores the number of recognized objects by calling this function. So this just gets you how many objects the camera recognized in the frame. And then I have, I call another function, and that gets me a pointer to a list of recognized objects. And you'll notice that it's constant. The reason why it's constant is this is not allowed to be modified. So once I get how many objects I have, as well as a pointer to the recognized objects, I simply iterate through each of the objects using a for loop. And how you tell what the object is based off of its recognition colors we just talked about earlier. So if it was a victim, it'd be 000. And we have just a function right here called array equals, and it's right here. All we do is we take in a pointer to one array, a pointer to the other array, and the number of elements you want to compare. And then it just goes element by element. And if all the elements are equal to each other, then it just returns true. Otherwise, it returns false. So that's how that's what we use in order to tell if what we're looking at is actually a victim. And this is how you get the colors of the object in question. And if we pull up the documentation, sorry, and scroll all the way down here, we talked about this last week, but this is all the information you get out of a recognized object. You can get its ID, its position, which is its 3D position relative to your camera. its position on the image in terms of pixel values, size on the image, as well as colors. And this is what we use in order to find out what object it is. So we have an array called victim color that we just made, and we're just comparing that to the current object. And if those all those colors are equal, then we just print C victim, and we can do whatever we want with the victim then on. If you wanted to have a case for a wall or an activity block, then pretty much you do the same exact thing. You do this array equals probably in like an else if statement like this. And you'd have your objects I.colors, and then let's say you have another array called yellow block or obstacle, any of those. And then you do right here what you want for that case. All right, any questions so far? Okay, and so if we take a look inside of this case, the first technique that we're going to introduce is pretty simple. It doesn't require any kind of like hard math. The idea is that as long as the object is centered within the middle pixel of our screen, then we simply move forward. And eventually we know that we're going to hit the object and we're going to be able to collect it. And how collection works in Airbus right now is that if you're within a certain radius of the object for a few seconds, a set period of time, then you collect the object and the object disappears. So what we're doing right here is we get the position of the victim on the image using this. And we care only about the horizontal pixel position, not the vertical pixel position on the image, because the horizontal pixel position is going to tell us if it's to the left or to the right of the front of the camera. So specifically, that is at index 0 of position on image, and then we just store that in a variable. And then we just have these two statements. We check if it's greater than the cam width divided by 2 plus 1. And how we got cam width was right here. We just call a function cam get width, and we store that inside of a constant integer because that shouldn't be changing. So if it's greater than cam width plus 1, then we know it's to the right, and that means we start turning left. Else if it's less than cam width divided by 2 minus 1, then it must mean it's to the left, and then we start turning right. And the reason why we do plus 1 and minus 1 is to give it kind of a buffer zone for what's considered in the center. If this is too small, then you're probably never going to get in the center because it has to be so exact. But if it's too big, your turning won't be too accurate. All right, so otherwise, we just move forward. And eventually, the idea is that we'll hit the object and collect it. So if I build this, run that, actually reset. So let's say I just move it here, for instance, just for example. And then we run. There you go. So right now we're not focused on mapping or anything. So we're just going to place the robot in front of the victim for the sake of demonstration. And next, our second technique is going to require a bit of trigonometry, like we said. And I have another bit of code written here. And I'm going to walk you through with that as well. And before I do that, I think Jeffrey is going to explain some of the math for those of you who haven't reached that point yet.
Okay, so I'm going to share my screen. So for those of you who haven't really done trig yet, this might be a little complicated for you. But in summary, for trig, those of you who do know it, we have sine, cosine, and tangent. Let's take this triangle right here. If I take the sine of an angle theta, it's just going to be the opposite leg, in this case b, divided by the hypotenuse, which is c. Now I know b is the opposite leg because it is the leg opposite to the angle. In other words, it is the leg that is not touching the angle. So you see that both c and a are touching the angle. So b is going to be the opposite leg, and a is going to be the adjacent leg. So we define sine of theta as b over c. We define cosine of theta as a over c. We define tangent of theta as b over a. So sine, cosine, and tangent are all functions, and what that means is I take an input. In this case, it's an angle theta. It's this angle that we're talking about. And I can input it into the sine function, and it'll spit something back out. For example, if I take the sine and I pass in 30 degrees, if this was a 30-degree angle, then I would get 0.5 back out. That means for any right triangle with an angle 30 degrees right here, this side divided by this side will always equal 0.5. So that's like a really brief explanation. We have another video already posted that explains the trig in a little more detail. But the reason why you need trigonometry for this particular challenge is victim delivery, as Victor said before. So in this scenario, let's say I have my robot right here at this point, and it's facing straight up. Then I have a human that I want to go collect. So my camera is facing this way, and it spotted a human out of its peripheral vision. And as Victor said, whether using C++ or Python, you can get a list or a pointer to all the objects that the camera recognizes. And when you do find the actual object that is a human, you can actually get the coordinates of the human relative to your robot. So let's say in this scenario, my robot is right here. And since the coordinate of the human is always relative, we're just going to mark the robot as 0, 0 always. And now let's pretend the human is over at 5, 10. So we need to know two things. We need to know, one, since my robot is facing straight up, we need to know how much my robot needs to turn to the right so that it's facing directly at the human. Then we need to figure out how much my robot needs to go forward so that it stands right next to the human. And so basically we're looking for two things, an angle and a distance. So to help out, we can actually draw a triangle out of this situation. And this triangle is pretty useful for several reasons. First off, this angle right here, this angle within the triangle, that represents one of the things that we need to know. This represents how much our robot needs to turn to the right so that it's facing the human. Then this hypotenuse is just the distance that we need to travel so that we get right next to the human. Also, since we know that this human is at coordinate 5, 10 relative to the robot's 0, 0, 5 is the x-coordinate, so we know that the x displacement is 5, so this leg is a length of 5. And we know that the y-coordinate, for the same reason, we know that this leg is 10. So let's fill in all the information. So we know this is 5, this is 10. We're looking for theta and x. And now since this is a right triangle, we can both do trig and use the Pythagorean theorem. So you can calculate x just using a squared plus b squared equals c squared, no trig required. But for the angle, you will need trig. So if we take a look at our basic functions of trigonometry, we have sine, cosine, and tangent. So just like with any plane trigonometry problem, we have to figure out which function we want to use. And since we weren't explicitly given x, we're going to assume that we don't know the hypotenuse. So if we look over here, we see sine uses hypotenuse, can't use that. Cosine uses hypotenuse, can't use that. So we're going to use tangent. And we can set up this equation. Tangent of theta, this angle right here, equals the opposite leg, which is 5, divided by the adjacent leg, which is 10. And then to isolate theta right here, we can take the arctangent of both sides, and we have theta equals the arctangent of 5 over 10. Now, most of you are probably most familiar with expressing angles in degrees, like I have a 30-degree angle. But there's actually another unit that you can express angles with. Just like when you express the lengths, you can use like inches or centimeters. For angles, you can actually use radians or degrees. And when you code using trigonometric functions, those functions actually use radians almost always. So that means if I use a tangent function, I'm going to have to give it an angle in radians, because tangent takes in an angle and spits out a ratio. On the flip side, arctangent takes in a ratio and it spits out an angle. So this ratio, since this is just the ratio between lengths, we don't have to worry about degrees or radians. But this atan gives back an angle in radians. So if you want theta to be stored in degrees, all you have to do is take the output of this and shove it through this formula right here. So we just take the output of this, multiply by 180 and divide by pi, and that will convert our angle into degrees. So now we have the angle that we need to turn to the right, and then we have the distance that we need to go forward. Now, one thing to keep in mind is this human could always be on the left, but if it is on the left, then the x coordinate should be flipped negative instead of positive, because this human is always given relative to the robot. So if you keep your x coordinate negative and you take the arctan of -5 over 10, this value will actually come out negative instead of positive. So from that, you know that if my angle is positive, that means the human is to the right. And if my outcome from this is negative, that means I know my human is to the left. So that gives you what direction you need to turn. So now you know what direction you need to turn, you know the angle you need to turn, and you know the distance that you need to go forward. So that's just the math behind the victim retrieval with trigonometry. So if you have any questions, make sure to send a chat to our moderator, Miss Elizabeth. So Victor, you want to take back over?
Yeah, sure.
Okay, I'm sorry, excuse me for a second here. Before we go further, I want to give a moment for everybody kind of digest what Jeffrey has gone through. Does anyone have questions? Okay. Well, do not be afraid. Like maybe put a message in the chat if you want us to like repeat any piece of the information. Okay, so then Jeffrey I'm sure that they would love to answer your questions. So please do give us questions, anything. All right, thank you. Yeah, go ahead, guys.
Okay, before we continue, we did get one question, and it says, the object collection is kind of glitchy. What should I do to fix it? If you're talking about the victim collection, there's a few things I'm wondering. What do you mean by glitchy? So if you could clarify your question, that'd be great. Do you mean like it's not collecting? And I actually do have something to say about a bug you might find with the victim collection. It's not really a bug, but it's not really something people know about. So if I share screen.
Okay.
So if you were to move these victims, something people don't know about initially is that if you were to move these victims right next to your robot and then you try collecting it that way, that is not actually going to work. And you'll see for a moment. And the reason why that doesn't work is actually the game controller is constantly monitoring the position of your robots and looking for if your robot is next to a victim. And they don't associate it with the physical location of these victim objects. They actually associate it with the ground where the victim is. So depending on how you collect this victim is really dependent on whether you enter that radius in the space in the simulation and not if you're physically touching this victim object. So if that was your problem, I hope that fixed it.
And
I'm
also,
going to unmute Itash for a little bit just to make sure that his questions is answered. Now, I'm sorry, guys, I have to mute everybody because, well, for security reason. I'm sure you understand that. So, Itash, I'm going to mute for you for a moment. So go ahead to clarify your question. See if you think that Victor has already answered you, okay?
So what happened was like I don't even move the victim. What I do in my code is that I did the first method, which like you turn the object is in the middle of the camera, like the camera's like view, right? So and then like I go to collect the object, I hit the object and stop for like a good 5 seconds and it doesn't pick up and it didn't move the object either.
Okay, you know that you can only collect one object at a time, correct?
Yeah, that was the first object. It just didn't pick up.
All right. And also you didn't move the physical location of the object, right?
No, I didn't.
Okay, in that case, I guess we can address your problem after the meeting is over, and then we could look at your problem individually.
Okay.
something quick you might want to try is drag the robot using like the axis arrows, drag it next to the victim and see if it collects.
Okay, I'll try that.
All right. So as Jeffrey introduced, the next technique we're going to use with a bit more trig. So this is just another sample program I wrote up. And you'll notice that we have a lot of the same functions from the box challenge we wrote earlier. And we're going to be using these same functions in order to do this version as well. And to give you a rundown of what it does, we introduced the same idea of the state as last time. So we can be in multiple states. The first state the robot starts off in is state 0. And this is the victim scanning state. And you'll notice this is pretty familiar to what we had earlier, where we're going to iterate through a list of objects, and we're going to check which one is actually a victim. Now, what we do differently this time is if we do see a victim, then we calculate the angle and the distance to the victim. And then after that, you'll notice we use the ATN function and the vicpos of the x divided by the vicpos of the z. So since this is three-dimensional, remember that z is one of the flat axes. Remember that y is always the horizontal axis, not the vertical axis, I should say. And the x and z axes are flat. So that's why we use the position at index 0 and the position at index 2, because this is x and this is z. And then we convert to degrees like so. And for distance, we just use the Pythagorean theorem. Afterwards, we switch over to state 1 and we activate our turn. So in state 1, we are just turning towards the object the correct number of degrees. And once we're finished with state 1, then we start moving forward and transition to state 2. And state 2 is just moving forward the correct amount. After we finish moving forward, we just stop. Okay, and if you want a description of these functions, please go revisit our box challenge video that we made. So if I run the program, And this is just a warning. We don't really care too much, you know, it's not gonna crash our program. All right. And actually, let me see if I can. So we don't, oops, don't want to move that. All right, so we have our robot right here. And remember, this is for the purpose of demonstration. This code is not complete at all. And a few of the things that we don't take into consideration is that Jeffrey was talking about if the robot is to the left, then you have to negate your angle, so you turn the other way. Our code currently, for this sample code, that does not do that. It's the bare bones of what it does. It just turns to the correct angle and moves forward, which is why we have to like move the robot around. But in the next video, once we get into mapping and navigation, you'll see a complete demonstration of what it can do. So if I run this, it calculates the correct angle and then it finishes. All right, so that's about it. That concludes our 2 techniques that we introduced you guys to. And it would be good if you guys expanded on this idea particularly. Remember I said it's not complete. If you guys could find out, for instance, how to turn in the left direction, calculate your angle towards the left if the victim is displaced to the left. So now we'll be taking questions. If you have any questions, please send them to the moderator. And we have one question. I have missed the last few Q&As, and for some reason, whenever I want to download a controller onto a robot in Webots, the computer can't find the controller. I've tried moving the Airbus RA folder somewhere else so Webots can find it. Could you please give me assistance? And all right, also I send messages to everyone. Okay, so first the message sending thing is a matter of privacy and protection. So you can still send messages to the moderator and eventually we'll get to your question. And so as a matter of downloading the controller onto the robot, if you're following our tutorials and what we do, where we make C++ controllers versus like the Python controllers that Airbus is normally used to, I will share my screen shortly. All right, so this is what your Airbus RA project directory should look like. Ignore these files, these CPP files. That's something that we made. And if you're having trouble looking for your controller within the simulator, your controller should be saved in game controllers, and it should be saved within a folder inside of here. And for instance, this my controller is going to be the name of the controller, and within this controller folder, you're going to have all your CPP files. And normally, if you use the Airbus build tools, you're going to generate a make file within this folder. So everything within your controller is going to be enclosed in a single folder. And then if you look within the controller, if everything is set up correctly, Webots should automatically recognize your folder as a valid controller, and then its name should come up here. So I hope that helped.
Yeah, even if you miss the last few Q&A sessions, we have tutorials posted on YouTube. And we also recorded the Q&A sessions, and those are also on YouTube. So you can go and look them up. Each video is about half an hour, so it shouldn't take that long. You can just watch through all of them. They're pretty detailed, and it does cover your controller and any controller issues you might have.
I would like to add on one thing. Like, and then I know that like the YouTubes are kind of like, well, you have to go online and search it, but nevertheless, I have everything, all the links stored and accessible online through our website. So you go to our website. I'm going to put the website link on the chat. It's really easy to access. Just basically stormingsrobot.com, and you just go click on the robot simulation. All the links are all there. So including like exactly what Victor just said, or Jeffrey rather, and all the recording, all the video recording has been saved online, and they're all in one location so that you can access anytime you want, so that you don't have to go around to search it. So I'm going to put the link on the chat so that everybody can just go on there and visit, and you will get a lot of information from there. Then there are a lot of recordings, very good recording tutorial. And later on, that I understand that Jeffrey and Victor also post some sample code as well. So just keep our eyes open and access the website anytime you want. Okay. Yeah. Go back to Jeffrey.
Oh, he has a follow-up question. I copied the C++ Hello World code from the video, and it is saved in here. It says it needs to find a file, not just a folder. Okay, so once again, I think the video should go over how to build your C++ programs, but not only do you need to copy the C++ Hello World code, you also need to use the make file in order to compile and link your code. So the idea is that from your CPP code, you want to produce an executable program like a .exe. So that .exe should go as well inside of that folder. And once you make the .exe, that's what Webots is actually attaching as the controller. While it looks for folder names, what it actually attaches is a .exe. And does the make file need to be a .exe file? No, so we go over this in detail in the video for once we first make a C++ controller. I'd recommend you take a look at that and maybe rewatch it, because the make generation process does take a while to explain. All right, any other questions for that?
Okay. Are we looking through questions? I believe someone started typing just direct to you guys, so I don't see it.
Yeah, I think so.
Okay. Itash, you said that you want to have a question, but do I need to unmute you so that you can ask that questions, or you actually have already asked? Okay. Okay, very good. So then someone were interested to see if you have any sample codes posted somewhere. So I guess it will be on the video, or Jeffrey, Victor, you're going to give me the link so I can put it on the same website that they can access probably, right?
Yeah, we can do both. Usually sample code will be posted in the description in the corresponding YouTube video tutorial. So this week
Oh,
is
okay.
number 4. So yeah, we'll put it in there.
Okay,
And
awesome.
we can also send you a link, yeah.
Right. Okay. Awesome. Like what I said, when they put all the links corresponding to each video online with the video itself, right? However, the links to all the past videos and the future will be all accessible through our website. So I just, like what I said, do look at the chat. I put the link there. So it's like a one link so that you can get to all the videos that we had before and future too, and the sample codes and everything. Okay. I think, is there anything you'd like to add?
Real quick, this week's sample code is not up yet, but we should be putting it up pretty soon.
Okay. Now, one thing I'm going to put an email address here. I'd like you guys go ahead to send me what you'd like to know. So then you have some time, go through the video, and as long as you want, as many times as you want. And I think that I'd like to arrange a meeting trying to address everything that you may have, or you may not understand, or you may want to explore. And then we will set up more webinars to help you in that particular areas. But I'd like to hear from you and see what particularly which areas that you want to be, you're interested in knowing, or you have problems with. So do email to the office at stormingrobots.com, and I will try my best to gather another meeting just to pertaining to all the questions. I think that would be very productive that way. Anything else, Jeffrey, Victor?
No, that's about it.
Is that about it?
And
Okay.
we can help the person about the victim retrieval if they want, if they stay.
Okay, so yes, I think we're going to just keep the meeting channel open for a little bit, and for about probably another 10 minutes only. So then, so that if you have any questions, please feel free to ask. Put it on the chat. Is there anything that you guys want Victor and Jeffrey go through again, like the math stuff?
I think for the most part, should be good. If
Yeah,
you
these are
haven't gotten, yeah, if you haven't gotten to like trigonometry yet, don't worry. Well, it's pretty basic where you can
Let's go.
take a look and just like recognize the relationships of like tangent, arctangent.
Yeah. Okay. Like what I said, I'm going to post two things to end. I'm going to end the meeting soon. Two things. Do sign up for the notification to the Robocop Junior for the Future Robotics Simulation League. And second thing is do email me about your questions. And also, if you sign up, I did get your email address. I'm thinking about setting up some kind of forum just particular for us, so that you can post anything you want. We can communicate all our questions so that we can share. Okay, so that I think I'm going to end the meeting right now. So thank you guys for coming, and then next meeting will be next Saturday. And again, all the videos in the future will be posted as well at the link that I put in a chat. So do go to that link, because that's where everything's in, so that you don't have to go all over the place, type different link. Okay. So thank you for coming. So I see you next week.
Oh,
Or I hear from you
there's
soon from the email, or it'll be great. All right. Thank you, guys.
there's one person that
Yep.
might want to stay after for help with some building
Oh,
issues.
okay. Yeah, I'm going to leave now. So I'm going to leave that to you guys, to Jeffrey and Victor. Okay. If you guys have any particular questions, those the two speakers are going to stick around. I have to run because I have another class. All right. Bye, guys.
Jeffrey, Victor, who was it that wanted to stay after? Was there someone in particular?
Yeah, Antonius, I believe.
Okay,
If you
I
want.
can, okay, hold on, I'll unmute him. Antonius, are you there?
Yes, I'm there.
Okay, good. Okay, so you guys, did you need help with something?
Oh no, we're just helping him build his programs.
Oh, okay. All right. Well, go ahead.
Okay. If you want, do you want to like share screen, or we could just go over the build process from the beginning if you want?
I want to share my screen, but
Okay.
it
Oh
says
yeah.
disable participant screen sharing.
Dennis.
All right. Hold on a second. Hold on one second. Whoops. Close. Okay. Try it now.
Okay. So this is the makefile that I modified to say cxx sources equals tutorial.cpp, which is this one that I literally copied all the code from the video.
Okay. What happens when you press build?
When I press build and what?
What does it print out? Or actually, you could show me the folder hierarchy as well. All right. What's under controllers?
This one's the one that I was trying to do.
Build makefile tutorial.cpp. Okay. All right. So if you go back to Webots and you press that gear button, what does the console print out? Make updating tutorial. Compiling. And okay, so that gear button is what you use to build your program. So before, every time like you write new code and then you want to like you want to run it in the simulator, just press that gear button and
Oh.
yeah,
By the way, it's end L, not end one.
yeah, end L. That just stands for end line. And if you save that and press the gear again, I think it should work. All right, there you go. So if you go back to your folder, I think you should see the .exe in there.
Oh, the my controller 2.exe.
Yeah, all right. Now you can just attach it and it should work.
So should I reattach it?
Yeah, before you
Do you
do
want
that,
to reset or reload the world?
you can just exit out of that. It doesn't matter.
So do I just reattach it?
Yep. Actually, you don't even need to reattach it if it's already attached. Just
And now
reset
I
the
just
simulation.
reset it and press play.
Yep.
Do I also press play here?
Yes. Give it a moment.
Uh-oh. Oh, man. Yikes.
Is this a laptop you're running it on?
No, it's a desktop.
A desktop? Oh yeah,
Because
that's
printed
another thing.
Hello World.
Yeah, it did print Hello World. One thing is, just make sure your antivirus is not blocking it or something, because it just sees like you're running a CPP program and it might get suspicious. That it might have hung up because of
Oh.
that. I don't know. So just check with your antivirus, and you might want to specifically allow it to run your Webots programs. And besides that, that's pretty much the basic idea of how you want to build your programs.
Okay, thank you.
No problem.
All right, guys, is that it? We're wrapped?
Yeah, unless anybody else has any questions, that should be it.
Okay, goodbye.
All right, bye-bye. All right, everyone, I think we're going to close the meeting out now, okay? So thank you very much for showing up, and we'll see you next week, same time. Bye-bye. Oh, wait, Etash has a question. I'll unmute you, Etash. Hold on.
I was talking about the victim collection earlier.
Oh,
Yeah.
okay, yeah.
You guys said you were gonna talk about it.
So what was the problem you were having with the victim collection?
It was like, so like, it just like, so my code, what it did is that it just like hit the human and then stopped there for 5 seconds and it didn't pick it up.
Okay, so when you moved the robot manually to the victim, did it pick up the victim?
I haven't tried that because I'm fixing my code right now. But I could try that right now.
Okay.
It's not picking it up. But it's the simulation is paused.
All right. If you
No,
want,
it's literally not picking it up.
if you
Other-
want,
picked it
you
up
can
by-
like share screen and we can take a look.
Okay, sure. Now I'm gonna move the robot in front of the screen.
Could you bring it to like a top-down view?
Oh, and that's turning because I made a coordinate to me.
All right, so put it like, yeah, right next.
It takes a really long time.
Oh, well, it picked it up, right? And also after that, you won't be able to pick up another victim. Just remember that until you deposit it.
I realized that when I was
Yeah.
coding. So like, wait, so, and I have another question. It was like about the camera objects thing.
Uh-huh.
So like, when I'm like trying to iterate through the camera objects, like, do I have to do this? Or like, to get the
No. For cam objects, and then you want to get position on image, that's a dot. It's not an arrow.
Oh. That.
Yep.
Yes, I was.
Yeah, same thing for colors as well. And you have some other places where, oh, also position on image, remember, it's an array of 2 values
Okay.
of like an X and a Y. So
Yeah, it's just it was a one.
that's because get recognition objects is Also an array. So yeah, just remember like the difference for, in your case, you can look on the documentation of what it returns. If it returns an array or a pointer for that matter, you have to index it.
Yeah, but like here, like this is not an array. I looked in the documentation.
Sorry, what?
Wait, never mind, never mind. This isn't. Yeah, this is an array. It's supposed to be numbered. How do you do? What is the the number of objects function again?
Get get recognition number of objects.
What is going on? Get recognition number. No.
Yeah, so that part we probably won't be able to help you too much with in terms of like the actual coding part. We're happy to answer any questions, and
I think I just broke the code.
okay. Do you have
Yeah.
any more
No, I don't
questions?
have any more questions.
Okay. Oh yeah, just fix up the places in the rest of your code where you do that as well.
Wait, it was supposed to be ID. Yeah, ID is an integer.
So the get recognition number of objects, if you look on like the Webots documentation, right, it returns an integer, right?
Yeah.
So you can't get the ID from the get recognition number of objects. You can only get it from a recognized object.
No, yeah, that was, yeah. This was
And
supposed to hold ID. This is supposed to hold ID.
and
That was
remember,
my point.
so get recognition objects, right? If you look on line like 65, get recognition objects, that returns an array. No, 65. That's going to return an array of your objects. So you can't get the ID like that. Do you understand?
Yeah.
All right.
Does that work? Okay, yeah. Yeah, now I'm done. For now.
All right, cool. And I guess we can stop sharing. All right. I think that's it, Dennis.
All right. Thank you for coming, everyone. We'll see you next week. There doesn't seem to be any more questions. So see you all next week, same time. Bye-bye. All right, I kind of tossed them all out into the waiting room. So they'll get the picture at some point. There's only one left. All right, guys, great job. Luckily this week we had no one screaming at us. Hold on a second, I'm gonna stop recording.